Astronomers have recently made a groundbreaking discovery using the cutting-edge James Webb Space Telescope, uncovering the most distant globular clusters ever observed in the universe. These clusters, consisting of millions of stars, could represent the remnants of the very first stars formed after the birth of the universe. This discovery holds the potential to reshape our understanding of the cosmos, sparking questions about the formation of galaxies, stars, and the very early moments of the universe's history. What exactly did the James Webb Space Telescope uncover, and how might this discovery influence our perception of the universe's origins and evolution? Stay tuned as we explore the fascinating implications of this discovery. If you are someone who loves to keep up with the latest news from space and the universe around us, consider subscribing to our channel. Don't forget to hit the like button and turn on the notification bell so you never miss an update. One of the most exciting revelations came from the first science-quality images captured by NASA's latest and most powerful space telescope, the James Webb Space Telescope. Among these images, astronomers were amazed to find a distant galaxy enveloped by dense clusters of stars. These clusters, potentially containing some of the universe's earliest stars, are located a staggering 9 billion light-years away from Earth. A team of Canadian astronomers turned their focus to a galaxy they have nicknamed the Sparkler Galaxy due to its unusual, stretched shape and the surrounding compact objects that resemble small, reddish blobs. The galaxy's peculiar appearance, combined with the intriguing nature of the objects around it, led scientists to believe they may have stumbled upon some of the most distant globular star clusters ever discovered. So, what are these globular clusters, and why are they significant? Globular clusters are tightly bound groups of ancient stars that have existed since the galaxies they inhabit first began to form. These stellar clusters are scientifically invaluable because they can provide essential insights into the early stages of galactic evolution. The Canadian team examined 5 of these compact objects surrounding the Sparkler Galaxy and concluded that they are indeed globular clusters, possibly the oldest ever detected, dating back to the earliest epochs of the universe. As study co-lead author Karthik G. Iyer explained, the discovery of such an extraordinary object so early in the James Webb Space Telescope's data was unexpected. The ancient stellar systems around the galaxy are not just massive but also immensely ancient, making this discovery a key to unlocking the mysteries of the early universe. This breakthrough offers astronomers a unique window into the formation and evolution of galaxies and stars. The ability to date these ancient globular clusters could lead to a deeper understanding of how the universe itself has evolved over time. Iyer emphasized how the data collected from the James Webb Space Telescope allowed his team to study these sparks at various wavelengths. By analyzing the light from these clusters, they were able to model their physical characteristics, such as their age and the number of stars they contain. Before the advent of the James Webb Space Telescope, such detailed dating of the first stars in distant galaxies, especially within globular clusters, was impossible. In an interview, study co-author Lamola, an astronomer at the University of Toronto, further elaborated on the importance of this discovery. The ultimate goal is to date all objects in the universe, from stars and galaxies to globular clusters, to pinpoint when star formation first began. While we currently believe that there are around 150 globular clusters in our own Milky Way galaxy, their exact age remains a mystery. The discovery of these distant, ancient clusters offers the potential to provide essential clues about the early formation of the universe, which may help solve some of the most perplexing mysteries in astrophysics. Compared to younger objects, older globular clusters are far more challenging to date accurately, making this discovery all the more remarkable. The Sparkler Galaxy, as seen 9 billion years ago, presents a unique opportunity for astronomers to better understand the processes that shaped our universe. Since the globular clusters around it appeared younger at that time, it's like looking at a picture of a child rather than an adult to estimate their age. As astronomer Mula pointed out, it's much easier to determine the age of a 1-year-old child than that of a 50 or 55-year-old adult. Using data from the James Webb Space Telescope's NIRIS, near-infrared imager and slitless spectrograph, astronomers confirmed the age of these globular clusters. NIRIS detected no oxygen, a common element in younger star clusters, which further solidified their ancient status. This remarkable discovery was made possible by combining the powerful James Webb Space Telescope with the earlier Hubble Space Telescope and an astronomical phenomenon called gravitational lensing. Thanks to Albert Einstein's general theory of relativity, astronomers have understood that massive objects can bend spacetime, affecting the path of light as it travels across the universe. This bending of light, or gravitational lensing, works much like pressing a finger into a stretched rubber sheet. The heavier the mass, the deeper the indentation. In the case of the Sparkler Galaxy, the gravitational lensing effect created by the galaxy cluster MAX 0723 distorted and magnified the image, allowing the James Webb Space Telescope to observe it more clearly. Some of the surrounding clusters even appeared in multiple locations within the image, a direct result of this gravitational lensing effect. Despite these extraordinary findings, astronomers are still uncertain about exactly how much the galaxy cluster MAX 0723 amplifies the image of the Sparkler Galaxy. As a result, scientists are planning to create a more accurate magnification model to better understand the precise age and distance of the Sparkler Galaxy and its clusters. The team intends to use the James Webb Space Telescope to explore 5 additional giant galaxy clusters, hoping to uncover systems similar to the Sparkler Galaxy. This ongoing research will likely encourage astronomers to continue searching for other distant globular clusters in the future, providing even more insight into the early stages of the universe's evolution. There are currently 2 main theories about how these globular clusters formed. One suggests that they originated during the cosmic dawn, a period when the universe was still in its early stages of star and galaxy formation. The other theory proposes that globular clusters were primarily formed during the cosmic midday, when most galaxies and stars came into being. Regardless of which theory proves to be correct, the discovery of these ancient clusters has already had a profound impact on our understanding of the universe's early development, prompting NASA to push the boundaries of space exploration further by considering even more advanced telescopes beyond the James Webb. Data from Webb's F spectrometer and near-infrared camera have revealed astonishing results. 4 out of the 6 primary galaxies observed by the telescope exhibit extreme redshifts, indicating that they existed between 300 to 500 million years after the Big Bang. What's particularly striking about this discovery is that these galaxies seem to lack the heavy elements, such as carbon, commonly associated with younger galaxies in the midst of star formation. Given that the universe is approximately 13.8 billion years old, these findings suggest that our current understanding of the early universe may need revision. The scientific community is buzzing with excitement, as these new discoveries challenge some long-standing assumptions in cosmology, including the Big Bang theory. Though this model remains one of the most widely accepted explanations for the universe's origin, it has its flaws, such as difficulties in reconciling certain aspects of thermodynamics and the absence of a clear explanation for what caused the Big Bang itself. The discovery of galaxies as old as the universe itself also raises questions about the timing and scale of galaxy formation, prompting researchers to reconsider many foundational aspects of cosmological theory. In addition to these revelations, NASA recently tweeted about another fascinating galaxy cluster discovered by the James Webb Space Telescope. This cluster, which formed just 650 million years after the Big Bang, represents yet another puzzle piece in the ever-evolving story of the universe. Researchers believe that this young cluster will eventually grow in size and evolve into something similar to the massive Coma A656 cluster. The unique location of this discovery highlights an area of rapid galactic evolution, and thanks to the unparalleled capabilities of the James Webb Space Telescope, astronomers can now measure the velocities of these galaxies, confirming that they are part of a protocluster that will eventually coalesce into a larger, more powerful galaxy cluster. As this discovery unfolds, it has become increasingly evident that what we once believed about the Big Bang may not align with the latest data. The James Webb Space Telescope is continuously offering new insights that are forcing scientists to reconsider many long-held theories. While more data will undoubtedly be needed to either confirm or disprove these theories, there's no doubt that we are on the verge of a major breakthrough in our understanding of the universe's origins. What are your thoughts on these monumental discoveries? Share your opinions in the comments section below, and be sure to stay tuned for more updates as we continue to explore the vast mysteries of space with the James Webb Space Telescope.